We just printed what we wanted instead of having to build something from scratch.
Got you. Is it as simple as just hitting Control P?
Not even close.
Okay. Welcome to Translogic. I'm Jonathon Buckley. The Department of Energy is tasked with some pretty important duties, from overseeing the nuclear weapons program to energy conservation and production. It's a vital department of the United States government, but it also plays a big part in energy innovation. And some of those innovations could radically change how vehicles and the buildings surrounding them are powered. This whole place got off the ground due to the Manhattan Project. It's done things like completed the first bone marrow transplant. It's got the second largest supercomputer in the world. This could very well be the closest I ever get to driving an actual Lego car, because the PUV, or the printed utility vehicle, is made out of essentially the same plastic as Lego blocks. The only thing is they've added carbon fibre to the mix. It is street legal, it has lights, it has indicators, it has brake lights, and to be honest with you, it's kind of nice. I'm here with Scott Curran. He's one of the R&D staff members at the National Transportation Research Centre. So today we're here to talk about the PUV behind us. It kind of looks like a utility vehicle.
Yes, so it is a mobile research platform. And the reason it looks rugged is that it was originally designed to power houses that would go in blackout scenarios. And those kind of buildings would probably be in areas that would be more accessible from a rugged-looking vehicle.
Perfect. So you are using a generator in this as well. So it's an electric vehicle, essentially.
Exactly. So it's functionally an EV, and something this heavy and this massive, you can imagine, wouldn't have much of range.
Right.
So instead of putting a very large battery in it, we're taking the approach of we're going to store fuel on board, and we're going to have some kind of high-efficiency range extender. The additional benefit is if we're already producing electricity on board, well, we can connect to buildings in very interesting research ways.
Right, and so that's where it fits in with the AMIE project. Roderick Jackson is the group leader for Building Envelope Systems Research. Now, we're down here today to find out a little bit about this AMIE project. Now, obviously, AMIE is an acronym.
So it's an acronym for Additive Manufacturing and Integrated Energy. It's kind of two concepts that we brought together, one to enable the other. We're looking at integrated energy. How can we use the vehicle and the building in some synergistic relationship?
Now, as part of AMIE, we've experienced the PUV, but there is a second part of that, which is the house behind us.
Right.
And it works alongside the PUV, yes?
Yes. The house has about 3.2 kilowatts of solar panels.
Yep.
And so not only does it have solar panels, it also has on-site energy storage. The PUV can power the house, or vice versa, the house can power the PUV, all using wireless power transfer.
How did you manage to do that? Because my cell phone still doesn't have that.
So we have a very talented group of researchers over at the National Transportation Research Center who excel in novel wireless power transfer. And what's really cool about this project was it was the first demonstration of bi-directional. So charging your cell phone one way is very cool in and of itself, but being able to go the other way, from your cell phone to the grid, that's what we've done with this project.
At what point and for what reason did you decide, let's go with 3D printing for all of this?
It allows you to innovate at timescales that we haven't seen before. We had a custom part that would take 3 weeks to resolve, take 3 weeks to get another version. We printed the solution in 5 hours.
We're not vehicle designers, so the ability to design something in a computer and print whatever we wanted around whatever vehicle architecture we wanted, even something as crazy as wireless power transfer enabled electric vehicles, we just printed what we wanted instead of having to build something from scratch. So we could replace the entire top of this car with a carbon fiber piece, or we could come up with a different honeycomb structure that would really lighten the whole structure very well, but still maintain the strength.
We've got a hybrid powertrain. So we've got a 14 kilowatt lithium ion battery, and then we've also got a generator solution, which is using compressed natural gas as its propellant. So 35 miles of range just on the battery. If you use your compressed natural gas, you're going to boost your range up to 100 miles. So, you know, quite a decent range for a car that weighs 4,000 pounds. And it looks like a car that the Punisher would drive if the Punisher were a tech head.
It's not light though, because you think straight away when you hear the words carbon fibre, reinforced plastic, things like that, it may be lighter than your conventional vehicle, but it's over 4,000 pounds.
It's a robust vehicle, and we need it robust so we can do these odd research programs on this and not worry about breaking the thing.
How much fun is it being here, building on a campus where you can literally go next door and pick the brains of some geniuses to help you out?
There's an expert, a worldwide expert everywhere. However, it's challenging because we can't just do things that are incremental. If we do things that are incremental, there's no reason to do it here. The course of history was changed because of this place. How can I work on things that really transform history in a manner similar to like the Manhattan Project?
When I first arrived today, I assumed when I saw the PUV that it was just going to be, you know, like a 3D printed toy. But what's remarkable is the top fit and finish. They've managed to lay over like a kind of a resin that is actually perfectly flat and quite shiny. So even the bodywork, even though it doesn't look like it, is actually 3D printed as well.
So what's its duty now? Is it purely a showpiece to show what you can do, or is it still being used for ongoing research?
Both. So it is an active research platform, so we use it to evaluate different range extenders, but it is also a very neat demonstration for what a national lab can do for energy for both transportation and buildings. So a neat demonstration vehicle like this that really showcases the technology is good for us to be able to communicate that science.
Where do you see some of this technology being used? I mean, what kind of applications are we talking about? Commercial applications or consumer?
The answer is all of the above. When you think about the fact 2.3 billion people around the world that lacks access to reliable electricity, we're saying, how can we take this concept of the individual building being able to communicate with your vehicle, maybe scale it to a community? We can have microgrids coming up all the time. Hurricane Sandy. Imagine if you had the capability to utilize your transportation fleet to be able to provide supplemental power to those buildings that were without power.
Well, it's hard to explain just how interesting it's been being here at the Oak Ridge National Laboratory. The work that these guys are doing not only have the ability to change the way that we consume energy, but also the ability to transform lives all over the globe. And we just hope that it finds its way out of the laboratory and into our lives in the very near future. For Translogic, I'm Jonathon Buckley. We'll catch you next time.